Hello everyone, this is Gautam Kakani, and my topic for this capstone project is to suggest best trading options for a particular perishable food crop for a particular state among all the 29 states across India. Coming to the importance of this issue, Indian economy mostly depends upon agriculture. Almost 60 to 65% of Indian economy comes from agriculture. And unlike cash crops, I have taken perishable food crops into my account because perishable food crops need to be used within 2 to 3 weeks of harvesting. So a proper planning must be made prior to the plantation season in order to get huge farm price in case of exporting a perishable food crop, or to reduce or regulate the import price in case of importing a particular perishable food crop. In order to address this issue, first I ask myself a question: why do different states in India have different farm prices for a particular food crop in a season? Basically, there are two root causes for it. First one is because of the climatic conditions in India. India is a peninsular country, and it's basically surrounded by three big water bodies on three different sides. So each and every state will be experiencing different climatic conditions throughout the year. This in turn will affect the yield of a particular food crop in different states across the country. And the second root cause for this is the soil health. So I want to take these features into my consideration and build a machine learning model in order to suggest best set of states to trade a particular perishable food crop. In case of exporting a crop, I want my model to suggest the states so that the farm price will be higher. So the farmers will be getting huge profit gains. And in case of importing a particular crop, my model should suggest a set of states in order to reduce the import price of that particular food crop in the state. Other issues that can be addressed using this model are to predict the most profitable perishable food crop in a particular state for a particular season, and to help the traders to make high profit margins. And this is the primary reason for me to choose this project, because a friend of mine is into this trading business and trades a set of fruits from our state to northern part of India. And while discussing about his business, he said that it's a very risky one. They have to plan their trade at the starting of a particular crop season and talk to the middlemen at both importing and the exporting centers, the centers where the farmers sell their food crops. And the big problem for them is to choose which set of states or the regions to trade with. Um, Even though how efficiently they plan, they sometimes they won't. Most of the times they won't be getting the desired profit margins. So my idea of project came from here, and I want to implement it in a larger scale rather than sticking it to a particular center or a particular crop. So I want to take the state in in our country as my unit of analysis. Coming back to the factors that affect the farm price in case of weather conditions. I have taken sunlight, precipitation, temperature, and wind speed into my consideration because, as we know, sunlight is directly sunlight. The amount of sunlight a particular plant receives will in turn affect the yield of a particular crop, because sunlight is essential for photosynthesis. And coming to the precipitation, Indian uh, agriculture mostly depends upon rainfall, because most of the Indian land is far away from bigger water bodies. So the farmers directly depend upon the amount of rainfall a particular state receives. And temperature too affects the yield of a particular food crop. And coming to the wind speed based on the wind speed, if the range of the wind speed is is moderate, then the root of the plant grows deeper into the soil to stabilize the plant from the wind. So as the root grows deeper, it absorbs more amount of nutrients and water from the soil, and This in turn affects the yield of a particular food crop. So I want to consider these factors into my account in case of weather condition. And coming to the soil conditions, I have taken two factors into the consideration, and which are surface soil moisture and root soil wetness profile. There are two different set of data sets in my project, and the first one is related to the monthly data of different perishable food crops at different states across the country. I have taken top 10 most produced perishable food crops into my account starting from Jan 2020 2011 till December 2020 from National Horticulture Board of India, which is an open source. And coming to the attributes of my data sets. So firstly, if you see at each individual file contains the information regarding a particular perishable food crop in a particular year, and the attributes in that file are center name. This is the place at which uh, the information regarding a particular perishable food crop is collected, and followed by year and month values and weighted sale average price. This weighted sale average price is nothing but the farm price at which the crop is sold in a particular center, uh, followed by a retail average price and total arrival. Total arrival is nothing but the total amount of a particular food crop which is arrived at a particular center. My second set of data sets is related to historical weather and soil report of each and every state from India, starting from January 2010 to December 2020. And I collected this data from NASA's audit data access viewer and API. It is an open source data based on the geographical coordinates, longitude and latitudinal values. I collected all the historical reports of weather and soil of a particular state in a given interval of time. So for each state, I downloaded a single Excel file containing the data of each month from starting from Jan 2010 to December 2020. And the attributes in my data set are all sky surface part total. This is the photosynthetically active solar radiation value at a particular state, and the dew or frost point at 2 meters above the ground level. So the dew point is the point where the water droplets begin to condense and dew can form. So this can vary at different locations because the atmospheric temperature will vary according to the pressure and humidity. So based on that, we will get a dew point, and below that dew point, water droplets began to condense. So based on this dew or frost point, we can get a insight of the pressure and humidity values. And I have collected this maximum temperature at 2 meters above the ground level and minimum temperature at a particular area 2 meters above the ground level, and specific humidity at 2 meters above the ground level, and precipitable water, which is the rainfall, and wind speed at 2 meters maximum, wind speed at 2 meters minimum, surface soil wetness, and root zone soil wetness profile of soil mixture. And these two are related to soil profile, and all these factors are related to uh, weather data set. Coming to the EDA part of crops dataset, first I mounted all the Google Drive files and then imported all the required modules and libraries. And then using globe module, globe module, I got the path of all the individual Excel files in my Google Drive. So I have 10 different folders. Each folder consists of 11 different years Excel files related to a single perishable food crops data. And I loaded all these 110 different Excel files into a single data frame, and the final data frame looks like this. And if you look at the snippet of the final data frame, you can see that it's not well organized. So I cleansed the data and modified the entire data frame, and the final uh, crops data frame looks like this. And you can see that it's very well structured. Uh, and some of the things which I have done in modifying the data set are I deleted the unwanted rows. All the starting rows which are above this row in this old data frame contains of information regarding the crop variety, season, year, etc. In a single row, there is just information related to a particular crop. So I basically removed all those rows and stored the important information from those rows by creating a new column in the modified data frame. To rename the header files, so that it can be it is easy for us to understand what regarding the information in that particular column. And if you look at this center name in the initial data set, it contains the information regarding the center at which this data is collected, and this column values too contains of non-English alphabets. So what I did is I replaced these center names with the states, respective state names of these centers, and removed unwanted uh, characters from this string, such as this, and modified that to a new column. And I even reshaped the data frame so that it will be easy for me to join it in the join it with the weather data set in future. So if you even look at this header files, for example, the whole data set consists of uh, W sale average price, retail average price, and total arrival. I simply have taken this W sale average price into my new data frame. I just want to consider this column because I don't want to focus much on retail price. I want to focus on the farm price. So I have taken this W sale average price, which is the average price at which the farmer uh, sells it to the middleman. And after doing all these things, and I even replaced the null values or the zeros with the row mean, and my final data set looks like this. Coming to the EDA of weather data sets, there are 29 files in this historical weather and soil data set, and each file contains the information regarding a particular state starting from the year 2011 to 2021. And if you look at the sample data frame of a single uh, file containing the information about a single state, you can see that there are some unwanted rows at the starting of the data set. And I dropped all these rows and retrieved important information from these rows, such as the state at which this information is collected, or the year at which the information is collected, and I created a new column, and from the information from and collected the information from these rows and added that to those column values. And after dropping these unwanted rows, I checked for the null values, and there are no nulls in this data frame. I visualized these row data using rel plot, keeping the hue as parameters. And the data I found out that there are no significant outliers in this data set too. And after creating a final data frame such as this, I even reshaped this final data frame too, Um, I modified this parameter. I took these unique parameter values and added that to the header file of this data frame and created a new column called month, which contains the information regarding the months in which the data is collected. While combining both the final data frames of historical weather and soil data and crops data frame, I again have to reshape those data frames in order to merge correctly. And after that, I plotted the heat map to check the correlation between uh, these features of my final data frame. And I expected that a lot of columns will be highly correlated, as most of these contains the information regarding uh, the weather data. But to my surprise, there are very few columns which are highly correlated, whose correlation is greater than zero point 0.8. After checking correlation among the column values, I removed the outliers of each and every individual column. So basically, I printed box plot of each and every individual column and checked whether there are any outliers. If there aren't any outliers, I didn't touch it. Or if there are some outliers, I defined my own interquartile range based on the box plot. For example, in the code snippet below, you can see that there are some outliers in this precipitation column. So I defined my own interquartile range and deleted the values which are greater than the upper limit, where there are outliers, and didn't touch the lower limit. And likewise, I checked the box plot of each and every individual column and remove the outliers. And after finally removing all these outliers, there are 17 columns and almost 22,000 rows in my final data set. Coming to the implementation of machine learning models, as of now, I have two different techniques in my mind to design the model. So first thing is using multi-class, multi-level classification algorithm. So in order to make this data frame as a categorical data set, I want to divide my farm price into of each individual crop into three or four different slabs, um, such as high profit margins or low profit margins or loss. And based on this categorical value, I want to train my model, and for a particular crop, it have to say under which categorical value it falls, given the features, all the necessary features. And for this, I am planning to use k-nearest snipers. I mean, the classification algorithms such as k-nearest neighbors, decision trees on name base, and by performance analysis will be based on the confusion matrix, precision on recall values or F1 scores. My second supervised machine learning technique to predict the farm price is using the regression methods. And using different regression algorithms, I want to train my model and predict the farm price of a particular perishable food crop in a particular state, given all the required features. And I want to compare uh, different models of the different machine learning algorithms of regression methods using performance metrics such as mean square error and absolute mean error. And as of now, I'm done with the EDA part of my data frame, and I want to continue with my machine learning machine learning algorithms. And that's it for now. Thank you.